Hi, Merkle Math is a gas-efficient library to find logarithms and powers on-chain inspired by elementary school log tables. What happens is we look up the value of log off-chain and then we prove it on-chain using a Merkle tree. So a quick demo, let's find the log value of 120. We need to approve the transaction as the state on the blockchain is updated. So as the transaction gets approved, let's look at the theory. So uh, we have decentralized finance protocols like Uniswap and Balancer, which require logarithm and exponent operations. So all of such operations were being solved by an algorithm. So you see, this is Uniswap's log formula. So we do a number of shifts, and finally we find the log of 2, and then uh, we apply change of base rule to convert it into log of some other number. So you see, it's a very long algorithm and it's very inefficient. It takes around 9,000 to 10,000 gas to find log of one number. So what we used to do in school is we would find the log of a number by looking up into a table instead of calculating it by hand. So that's what we are doing here. So we have a log table like this, and we converted it into a Merkle tree, and we stored its Merkle hash inside the smart contract. You see, this is the root that is being stored, and this is a log function where we shall prove whether a Merkle value whether the Merkle proof for a logarithm is valid or not. And coming to the benchmarks, we see a 44% or almost a half. We see that the gas performance improved by 50%. So here is we had ABDK doing gas around 9,000 to 10,000, and our algorithm is pulling gas around in the range of 5,000 to 5,500. So I suppose the transaction has been approved. You see 120, the log is 2.07. So looking at the code now, we have the front end that was just demoed, we have the contracts, and we have the generator code for the Merkle tree generate. So we are computing a log table, log, then we convert it into a fixed point number, and then we store it inside the tree and find the Merkle root, which gets stored in the smart contract. And finally we are generating these benchmark files in tests. So I go to Merkle Math, and we see we are iterating along a number range, and um, the value the benchmarks get stored over here in the benchmarks folder, and we use the CSV files to compute to generate a table. Here is the benchmark table that was just demoed.